Assalamu alaikum everyone. So today our presentation topic is three address code, and let me introduce to my teammates. We have Maksuda Tabassum, Meharunisa Maisha, Yasin Ahmed Abdullah, Tanjimul Astak Siam. And what we will cover foundation, representation, work example, one which will show translating an arithmetic expression, work example two which will show a second more compact expression showing common sub expression sharing, and we will also show real world TAC. And myself Ushal Binte Shahnawaz, and my ID 2421520, and today I will present about what is three address code. So three address code is an intermediate code used by the compiler. The main idea is that each instruction performs only one operation, so complex expressions are divided into smaller steps. For example, we have the expression x plus y into z. First, we calculate y into z and store the result in a temporary variable. And let's suppose we call it t1. So t1 is equal to y into z. Then we add x with t1, and we get t2 is equal to x plus t1. This makes the expression easier for the compiler to understand and process. Another advantage is that the order of calculation is clear and the compiler can easily optimize or rearrange the instruction. Next slide, please. Okay, addresses and instruction forms. And now let's look at the addresses and instruction forms of three address code. TAC mainly uses three types of addresses. First is a name. This is simply a variable from the program such as X or Y. Second is constant such as 5, 10, 20, 25. Third is temporary. These are names like T1, T2, T3, which are created by the compiler when needed. There are also different types of instruction. For example, an assignment can be x is equal to y plus z, and a copy is simply x is equal to y. A jump uses a statement like go to L. We also have conditional jumps, procedure calls, array operation, and pointer operation. So these are the instructions from the allow three address code to represent different operation in a simple and organized way. Thank you.
Okay.
Assalamu alaikum. I'm Maksuda Tabassum, ID 2421545. So my topic presentation is quadruple, triple, and indirect triple. Next slide. Now let's look at the syntax tree versus tag. Now, in syntax tree, the common sub-expression b minus c is calculated twice, which causes repeated computation. But in DAG, the common sub-expression b minus c is represented only once and reused. So that helps reduce redundant calculation and make the code more efficient. Next slide. Implementing three address code. There are three main ways to represent three address code: quadruples, triples, and indirect triples. A quadruple has four fields: operator, argument 1, argument 2, and result. A triple has three fields: operator, argument 1, and argument 2. The result is identified by the position of the instruction. An indirect triple uses the same three fields as triples along with a pointer list. This makes code reordering easier. Next slide. Same code tree representation. Here we can see the same tree address code represented in three different forms. In quadruple, the result is explicitly stored in a separate field. In triple, the result is identified using the instruction number. And in indirect triple, a pointer list is used to refer to the triple instructions. So all three forms represent the same computation, but they store the different information. Next slide. Comparing the presentation. Now let's compare them. Quadruple has more space, but they are easier to move or reorder. Triples uses less space, but moving an instruction can require updating reference. In indirect triples, uses pointers, so instruction can be reordered more easily. Therefore, indirect triple provide a good balance between compactness and optimization. So this was my part. Thank you.
Assalamu alaikum everyone. I'm Yasin Ahmad Abdullah. My ID is 242155516. So today we will discuss about our second example. So let's start. Next slide. So here we all see that there is an example given. First of all, we have to write down our three address code of the given example. So let's discuss about something in three address code. Like first of all, we have to calculate b by c, and we have to assign it in t1 variable. Then we have to calculate a minus t1 and assign it in t2 variable. After that, t2 power t2, and we have to calculate and assign it in t3. By this thing, we have to calculate other t4, t5, and t6, and how we and this way we have to write down our three address code. Okay, so next slide. Here we see that our syntax tree and the DAG are directed acyclic graph. So in there's a basic difference between the syntax tree and DAG. So in syntax tree, we can we see that one variable like a is used sorry, b or c is used variable times. Also we can see that d variable used 2 times, but in DAG we cannot use them multiple times. Here we see that our 4 variables a b c and 5 variables a b c and d e are used just 1 time. So this is the basic difference between the syntax tree and DAG. Okay, let's next slide. So here is the chart of quadruples, triples, and our indirect triples. So in quadruples, we see that there is 4 columns. One is operator, argument 1, argument 2, and our result section. In triples, here is just operator, argument 1, and argument 2, and one is like pointer type things. We just calculate 0, 1, 2, or we can point out 0, 1, and 2, 3, etc. So in indirect triples, here we see that one is simply is pointer type graph. So these are the basic three chart of quadruples, triples, and indirect triples. So I hope you are all understand. Thank you. This is from my side.
Assalamualaikum everyone. My name is Maharana Samaisha. My ID is 242155749. Next slide. Now I will explain the real-world application of three-address code. TAC is not only used for three-address code. TAC is not only used for arithmetic expression. It can also represent arrays, pointers, unary operations, control flow, and procedural codes. First, in the array and pointer example, x is equal to array I represents an indexed read, while array j is equal to w represents an indexed write. The AND operator gets an address, and the star operator is used for pointer differencing. We also have a unary minus operation and a simple copy operation. Next slide. The DAG represents the relationship between these operations. It distinguishes array reads from array writes and also represents pointer operation. Next, we have an if-else example. Next slide. TAG converts the condition into conditional jump such as if A is less than B, go to 108, and if false, flag go to 106. Function calls are represented using param and call. Temporary variables such as T1 and T2 store intermediate results. Next slide. Finally, the same control flow TAG can be represented using quadruples. Each quadruple contains an operator, 2 arguments, and a result. The jump targets allow the compiler to control which part of the program executes. Next slide. So the key takeaway from my section is that three-address code is not limited to arithmetic expression. It can represent arrays, pointers, control flow, and procedure calls using a small set of simple instructions. Arrays use index operation, pointers use address and difference operation, and conditions are handled using conditional and unconditional jumps. Temporary variables are used to store intermediate results. Thank you. That was our presentation.